Good afternoon, Howard Wiig, Code Green, ThinkTech Hawaii. I have as my guest today Mr. Tim Waite, the Senior Territory Manager for Hawaii and the Pacific Islands for Simpson Strong-Tie. What in the world is Simpson Strong-Tie? That's something we're going to find out in the course of our discussion. Tim has more initials after his name than I can possibly enumerate, but he, in addition to being president of Simpson Strong-Tie, he is the past president of the Steel Framing Alliance of America, not just Hawaii, of all of America. And he was years with the NAHB, the National Association of Home Builders, which, believe me, is a powerful organization. I speak from personal experience, having dealt with them. Mr. Waite is the author of, here's maybe the New York Times best-selling list, the National Training Curriculum for Residential Cold Form Steel Framing. Doesn't that sound like a bestseller? And also the author of Cost-Effective Home Building for the National Association of Home Builders. And again, he is a professional engineer, and he's got more initials after his name than I could possibly enumerate. We're going to start with talking about climate change and why climate change is, how it's affecting us in the Pacific, and how it affects our hurricane situation in Hawaii. I had the perhaps good fortune to be on the island of Kauai, I believe it was 1991, shortly after Hurricane Iniki. And we went up onto a ridge right by where the hurricane had struck. And I never saw so much blue tarp in my life. The first response of carpenters, they flooded over to Kauai, was to go to all the homes whose roofs had blown off and staple on blue tarp so that at least they could prevent the rain from coming in. And that whole ridge was one big mass of blue tarp. Very, very dramatic sight. And it taught me firsthand the necessity to face up to the fact that, yes, we are going to have hurricanes. And Tim, why don't you come in at this point and let's talk about global warming and the implications that has for hurricanes in Hawaii.
Thanks, Howard. And before we get too far, you had mentioned I was president of Simpson Strong-Tie, and I have to correct that.
Really?
But the senior territory manager here in Hawaii.
But aren't you past president?
No, not of Simpson, of the Steel Framing Alliance.
Steel Framing Alliance. Oh, did I that's what I meant to say.
But thank
Steel
you for the promotion.
Yes.
There's been talk in a lot of the magazines, especially centering around global warming, about all of the increase in storm activity that we can expect from that due to the, most people know that surface ocean temperatures, as they rise, it fuels more storms. And the ocean temperature around Hawaii during, especially in El Nino years, indicates that increase in activity like we saw last year, and can probably expect to see again this year. And so the journals have been reporting that as that happens over long term, we can expect more and more frequency of these type of storms. But even without that, the existing building code has provisions to, and it's been changed and updated where, if you're on the ridge, if you're on the side, if you're on a cliff, you have a certain amplification factors that increase the wind speeds that we need to build to and protect our homes. So we have new homes moving forward that need to have their roofs tied down and also have a continuous load path going down to the foundation. And we have a lot of existing homes out there that don't have any load path or hurricane ties in them at all. And that's where my company comes in, because we're a manufacturer of those products.
And when the slides come up, we're going to see reference to continuous load path. What is continuous load path?
Continuous load paths defined in the building code in the structural section of all the joints. Like you can imagine if you had a joint put together from the roof down to the wall, and for if you have two-story, from the second floor down to the first story, and then from the first floor down into the foundation, that all of those connections that were previously put together by nails, toenails, which have been proven to be pretty ineffective. That's the worst case for a nail because it's in withdrawal. It doesn't hold very well. And these ties or connectors that you put in reorient the nails and the fasteners so that they work in shear across the grain, so that they have better holding power. And so the building code requires this continuous load path to be met.
And again, we will see some slides coming up shortly there. But let's go over what I witnessed with Hurricane Iniki on Kauai. Can you just describe how the path got, I think it was to the south of us, and then suddenly it turned north, and we on Oahu dodged the bullet. But,
you know, as we know, we get better and better at predicting the storms, but Iniki kind of caught Hawaii by surprise with its turn. And if it gets caught, most of the storms pass to our south, and there's a really good website that shows that on the weather website, shows all the path of the different storms. When they make that sudden turn and have that, they're still strong before they hit the cooler waters, they can be devastating. And it's just with Eva and with Iniki, Kauai unfortunately got the brunt of both of those storms. But any one of the islands could get the force of a strong force of the winds. Our building code, if you look at the sustained wind formula in the code, has been 80 miles an hour for those storms, and Iniki far exceeded that. So you go from very little protection of homes that were built before 1995 to today, just the minimum protection for a hurricane of sustained winds of 80 miles an hour. So it's very important to at least tie your roof down in some shape or form to increase your chances of surviving a storm.
Yeah, well, I saw in your handout that I think Iniki hit gusts of 175 miles an hour.
That's classified as 3-second gusts, and today's building code is 105, and that's what any new house today would be built to. Of course, there's a lot of factors of safety involved, so you know, with winds at 145, with Iniki, it probably would fare better than those that didn't. A lot of the houses in the famous video of the roof blowing off had no connectors in them at all. So going from no connectors to some connectors is much better protection.
Yeah.
But even now with the 2006 code that we're building to, we see a lot of changes. If we didn't know anything about engineering or anything about the code, just based on the products that we're selling as a manufacturer, we've gone from a small tie that was valued at 400 pounds, to now we're selling more connectors, more hurricane ties that are being specified at 600, 900, 1,000 pounds.
And what does that mean, specified to 900 or 1,000 pounds?
So that would be equivalent to much higher wind load. You know, it depends a lot on the overhang. It depends a lot on the configuration of the roof. But the average Hawaii home, that would equate back to the wind speed that's in the building code now, 105 miles an hour.
And that may all change. Our mutual colleague, Gary Chalk, who's a civil engineer and one of the world's leading disaster preparedness type engineers. When there's a disaster, Gary gets flown over there to view the aftermath and see what kind of lessons we can learn. And he, for months, has been rewriting a wind map for Oahu. And something that he's finding is, because of our very mountainous terrain, what is true for the beaches is not necessarily true for the ridges, is not necessarily true for the valleys. So,
yeah, because of the research that he's done, and also with the University of Hawaii, they've generated separate wind speed maps for each island based on modeling. And I lived in Manoa Valley for several years, and I could always hear that wind coming and feel it amplified as it came down through the valley. So that's part of what Gary's project has been and is now incorporated into the building code.
Mhm. Okay, our slides are coming up. Let's, if we go to the next slide, which shows the path of Iniki. There, oh, here it is on the slide there. Look at that dramatic northward turn, and you can kind of see the Hawaiian Islands there in that path.
Yeah, most of them pass to the south, but occasionally you'll get one like Iniki that'll turn, make a drastic turn north.
And look at that damage, $3 billion.
And that's 1990s numbers.
Yes,
yeah.
yes. And the gross state product of Hawaii is only 72 billion. That's a big chunk of our gross state product right there.
You can imagine a direct hit to Oahu. That would be devastating.
Yeah. And a lot of that cost, I know from, again, personal experience, was getting all those roofs back onto all of those residences. I was trying to come back to Oahu on a Friday night, and that's when all the carpenters who were up there on those roofs got off, and they were coming back to Oahu to be with their families or just to spend their paychecks in Waikiki or whatever. And I think it was Aloha Airline at the time. They put on another plane. That got filled up immediately. They finally rustled up another plane, and finally at 10 o'clock at night or something, a whole bunch of us stragglers managed to get out. That was a huge impact. And you can imagine those carpenters getting all of that money, all that material.
Well, people had to react quickly. They had to protect what belongings that didn't get destroyed. And you know, it's amazing. You know, with 2 hits in the last 20 years or so, or 30 years, Kauai still understands hurricanes today. There's a much different attitude there than on the other islands.
Yeah, except maybe the southern part of the Big Island, which saved the rest of us from one of our very recent hurricanes. It hit the Puna region, and I guess Mauna Loa just kind of stopped it in its tracks.
Yeah, the albizia trees took the brunt down there.
Yeah. So it did us a favor by removing that invasive species there. Okay, let's take a short break, and we will be right back. ThinkTech Hawaii Code Green.
Okay, I'm Jay Fidel, that's Ray Starling. We co-host a show called Hawaii, the State of Clean Energy, every Wednesday, 4 to 5 p.m. It's really interesting. You know, Ray has a way of unzipping these guys. He asks them these questions, and all this stuff tumbles out, and we find out stuff we would never know about without Ray's questions. Thank you, Ray.
You're welcome, Jay. I'm very pleased to be your Ed McMahon every Wednesday at 4 o'clock here on the internet. So you can join us and see what's happening in the energy world, and there is a lot going on. So join us every Wednesday at 4 o'clock.
Yeah, come around, be energized right here on ThinkTech. Aloha.
Aloha again, Howard Wiig, Code Green, ThinkTech Hawaii. Tim Waite with Simpson Strong-Tie is my guest today, and we are talking about the fact that the island of Kauai knows hurricanes very well. The rest of us in Hawaii have dodged the bullet. It won't be forever. And we're going to be looking at some of the effects of hurricanes and what happens when you don't have your home tied down adequately. And the cost, we just looked at a cost of $3 billion that was caused by Iniki alone. Now here's a shot of, is that a roof that got blown off there, Tim?
Exactly.
Yeah.
It's a roof that got blown off. It was well braced together. As you can see, it all came off in one piece. But the problem was it wasn't tied down. It was just toenailed down to the structure that it was on, to the house it was on. Now you see 2 effects here. One, losing your roof, and then what happens to your neighbor's roof with the flying debris. So that's a example of no hurricane ties.
Yeah, you know, this has hanging around with engineers, I'm always talking about cost benefit. Yes, it will cost you a little bit money up front. What is the benefit down the road? And I can only imagine the cost benefit of putting in strong ties and then having a hurricane come.
Yeah, the material cost isn't really that much. It used to be, $400, $500 for the continuous load path on a house. I know today with the new code, it costs a little bit more than that, but for 50 cents a hurricane tie, compared with what you have to pay to somebody to come in to repair or tarp your house.
Yeah, we can only imagine the cost of just that one roof.
Absolutely.
You can't just have a crane and plop it back on there. Lord knows what you need to do.
Yeah.
Yeah, and pretty soon we'll see a overview of the devastation of that hurricane. Oh, here it is now. What are we looking at here?
This is Galveston Island after Hurricane Ike. This was full of homes, and one homeowner took a property and had it was renovating their home, and when they did, they installed a continuous load path on their house. So, I mean, you see other things going on here, tidal surge and everything in this area, but they now have no neighbors. Just for a few $100s of making sure they had a load path and built to the modern day codes, their house was spared.
Mm-hmm.
So it can mean more than just saving the roof of a house. It may mean the difference between having the house there after the storm or having it completely wiped off the map.
That is a very, very, very dramatic shot. Yeah. And again, the talking cost benefit, a few $100s, and you save, just from viewing that, tens and tens and tens of thousands of dollars, if not more.
That's correct.
Yeah. And on our next shot, we're going to see this continuous load process that you were referring to, so that we're tying down not just the rafters, but this looks like a two-story a home, a cross-section of it. Is that what's going on there?
Yeah, this is illustrating what that continuous load path is, and what it's doing is transferring the loads from the trusses down to the top plate of the second story, and then you have between stories, there's strapping between the second and first floor, and then down at the foundation from the first floor, tied down into the foundation. Mm-hmm. That would be the load path. It's more than just the hurricane ties at the roof level, but it's bringing that down into the foundation and holding that house down.
Yeah. And does that prevent both uplift and side shear?
Well, the continuous load path addresses more of the uplift components. Mm-hmm. There are other parts of the building code to address lateral, and usually that would consist of some kind of shear wall, plywood, mm-hmm. or strapping or something like that to resist the lateral component.
Okay. And on our next slide, a lot of our homes, mine included, are just single frame structures. And you think about that and it doesn't sound too sturdy, but here's a perfect example. This is a typical older home.
Yeah, there are thousands of single wall homes that have really benefited us in Hawaii over the years, allowed airflow, and most of them post and pier. But the problem is there are not any ties in them, so that they were really affected during the storms on Kauai and very vulnerable to that. Mm-hmm. So we were asked in the 90s if we could take a look at those homes and maybe we had a tie that we could use on them. And it's very difficult because with Hawaii type of construction, the freeze board, which is the board in between the rafters above the very top of the wall, it's not usually flush with the wall, it sticks out. And this is a good example of that, showing that top board there that runs along there is sticking out. So we had to come up with a tie that reached around that and grabbed the rafter. Mm-hmm. So we did a lot of testing, and a lot of people thought that the redwood tongue and groove board would not be enough. Usually we grab onto a stud to get that continuous load path. So we went back to the lab like we always do with our connectors to find out how they work and what kind of load we could get. And our target goal was around 400 pounds per rafter, which is what the old code, had for double wall construction. And this particular connector, because we used screws and we added embossments and bends in it, actually achieved 400 pounds, a little more than 400 pounds. So then we had something that single wall homeowners could use to retrofit their home and get a decrease in their insurance rates.
Mm-hmm. Glad you brought up insurance, because I'm an energy codes guy, but some years ago I was sent to a national conference in Des Moines, Iowa, which turns out to be the second insurance city of the nation, the first being Hartford, Connecticut. And one of these speakers talked about Broward County in Florida, southern Florida, encompasses Miami and Fort Lauderdale. And there was a terrific hurricane, this is many years ago. Homes blew down, and then they were rebuilt. And most of the southern states tended in the old days to kind of poo-poo all of this building code stuff. So the next hurricane came, the homes blew down again. At that point, the insurance companies became very concerned about the situation, and suddenly they were strong advocates of building codes. And if you wanted insurance, you had to show in Broward County that you were in compliance with the building codes that dealt with these issues.
Yeah, the insurance companies will only pay out money so many times. There's some talk in Kauai that was also, after 2 hurricanes, that they wanted the County of Kauai to enforce the code and strengthen the code a bit as well. It's important, but the biggest benefit to homeowners with a little bit of retrofitting is for their hurricane insurance. They'll offer 10-15% off their premium. So if you could actually pay for the retrofit within a very short period of time based on that benefit.
Yeah, that would be similar to a safe driver getting a automobile insurance discount.
Very similar, yeah.
And then we have another slide coming up that shows not only the strong ties in the rafters, but you're going all the way down.
This photo shows is actual picture taken back after the earthquake on the Big Island. We're post-impure construction on tofu block. Many of the single wall homes did very well, but if the shaking was enough that the post came off from the block itself, there was considerable damage to the home. So to meet today's code, you would not build like that. You would put it on an actual footing and have it anchored down with a column base, similar to what we manufacture, to keep that post from racking off and falling off the tofu block. And there are retrofit guidelines available to do that. It's University of Hawaii Hilo came up with a program. It's called Expert, I think, Seismic Expert. It's on their website. It's easy to search, where a homeowner could actually go in and work with that program and get a design and a hardware list on how to retrofit their post-impure home. And it's especially vulnerable to earthquakes.
Yeah. Again, specific to Hawaii. And this brings up kind of a personal topic, because my main function in life is to create the tropical energy code. And in designing with code a new home or homes for Hawaii, in conjunction with many others, am really emphasizing overhangs. The longer your overhang in our very, very mild climate, the more your windows and your walls are shaded from any direct sun heat. And therefore, let's say it's 85 outside, 75 inside, your temperature difference, which we call the delta T, is only 10 degrees when you're fully shaded. And as I'm working on this with a lot of other people, I keep thinking, the hurricane is not if, it's when. What's going to happen to these big overhangs that we're prescribing by code? It's an optional code, but it's there. Yeah.
Well, fortunately, the building code kind of goes hand in hand. You have the tropical provisions, which you're working on with the energy code to save electricity and provide a cooler home to live in. But at the same time, it has to meet the structural provisions as well. So while you have a large overhang area that's subject to the wind coming in and pushing up on the roof, you not just have the uplift, but you have a force underneath. You just have to counteract that with a continuous load path, and maybe instead of the smaller tie, you have to put a larger tie in to hold that down. It is achievable. It can be done. They've been building in South Florida, as you mentioned, like that for years. They have the stronger hurricanes, they put in the stronger ties. So we already have that available And once again, kind of like the insurance, it pays for itself not just in saving your home or your structure, but in the long term on your energy bill. I did that on my home in Kaneohe. I have 8-foot overhang over a deck, and it's really produces a very cool home.
Okay. And speaking of, you're going down all the way through the walls. The next slide is going to show us, I think, an illustration of exactly that thing.
Sure. Yeah, this shows the different type of ties that are out there. You have a very small tie that will satisfy a minimum wind load to a tie that actually wraps over the truss itself. This is very typical of the way they would build in Florida. And that would achieve, you can get 1,000, 2,000 pounds uplift and counteract. So if you're putting a large lanai, or even today on a carport area where you don't want the roofs to fly off, this would be the tie that you would use to counteract that uplift load, because you have that increased area of uplift. So you can enjoy the benefits of shading and still keep the structure from blowing away.
Yeah. And I'm just thinking, looking at that diagram, ideally this would be done during the construction of the new home. So everything's open, so people just get up on ladders and put these things in.
Exactly. It's always better to enclose it in the structure. If you have to retrofit, then you have to have extra protection because it's exposed. Hawaii's roofs are low pitch. It's hard to get into the attic space to install these things. So best it would during construction, but if you have to retrofit, then you have to protect them from rusting.
Yeah. Well, now you mentioned rusting. Wouldn't all these materials be totally stainless steel or some anti-corrosive?
We do make stainless steel. We make galvanized products as well. And the zinc on the coating of the steel protects it. It just depends on the exposure. If it's enclosed in the wall cavity, very little subjectivity.
I see what you mean. Yeah.
It has to have direct water, some kind of moisture content to get the corrosion going. If it's outside, like on my lanai, I use stainless steel just because I didn't want to be out there maintaining them all the time. And even stainless will corrode in over time in a salt atmosphere. So,
Yeah, it's amazing what salt can do. Yeah. On that cheery note, let's take our final break. ThinkTech Hawaii Code Green, back in half a minute.
Hi, I'm your host on ThinkTech Asia, Bill Sharp. I look forward to you joining us each Monday between 4 and 5 o'clock when we film right here in our studio in downtown Honolulu. The show, ThinkTech Asia, focuses on contemporary events in Asia. And by Asia, we mean anything from Hawaii, south to Australia and New Zealand, west to Pakistan, and as far north as the Russian Far East. Clearly, this is one of the most economically dynamic centers of the world, and we bring you up to date on what's going on in a whole host of countries in this very vital region. We look forward to seeing you. Aloha.
Good afternoon again. Howard Wiig, Code Green, ThinkTech Hawaii. Before we put on Tim Waite, our guest's new hat, which has to deal with steel framing, let's go through a few final slides of battening down the hatches, so to speak. This is literally battening down the hatches and giving different examples of the type of tie down that you can do. And here, is this just a simple little tie down here?
Yeah, this is the H2.5, and we've sold millions of these in Hawaii. It's good for 415 pounds of uplift resistance. It connects to both, you can see the double top plate in the picture. It takes 10 nails to give it the uplift resistance. And this has been the most popular tie up until the last building code change. The #1 bestseller of Simpson up until about 3 years ago.
And this is just a close-up of that again.
That's correct.
Yeah. Okay, and yes, please. And while I'm thinking, here's another one. Is this a slightly stronger type of
It
tie
is.
here?
This is the H1. It's good for up to almost 600 pounds of uplift resistance. This has gained traction because obviously engineers are looking for more uplift resistance. So this has overtaken our H2.5 in sales.
Mm-hmm. And then there's probably even stronger ties. We may see an image of that pretty soon.
Yeah, it's almost
Yeah.
like good, better, best. You can keep going. The H10 is a tie that's H10A rated for 1,140 pounds in uplift. And you can see it's a little bit bigger. It takes more nails. This shows the installed product here. And it goes up from there. We make several other products that get even higher to 3,000 pounds in uplift.
And something that occurs to me is I personally am in the energy efficiency business, but when we take measures like this, we get into the resource efficiency business. There was a heck of a lot of material that went into manufacturing all those roof components, more energy that went to bringing them to Hawaii, more energy that went into constructing them. They fly off and they may be totally useless. So it is definitely resource efficient to keep those things in place.
Yes,
Yeah.
both for the environment and for the homeowner.
Yeah. Keeping the dollars at home also, so he can do things like educate his kids or
Absolutely.
get a fuel efficient car. Yeah. So let's take off your strong tie hat and put on your steel frame hat. Out in the Ewa Plains, where most of the new residential construction is going, there are at least 4 what are called production builders. The builders who take, say, 20, 25 homes and develop them in a lot, sell them, move on to another 20, 25 homes, and so forth. And to my knowledge, 3 out of those 4 use for their framing, the things that hold the house up, they use steel frame. And only 1 uses wood frame, whereas on the mainland, I think it's only a small portion of all homes are built with steel frame. So what's going on here?
Well, it's an economic issue. Back in the late 80s, once again, the building code, the amendments to the counties and city of County Honolulu building code was to mandate the use of treated lumber for structural homes.
Mm-hmm.
And there's nothing wrong with using treated lumber, but what that did for steel framing was made it cost effective to use this product to build homes. So in the early 90s, we started seeing some of the larger developers in Hawaii switch over to experiment at that time with steel framing. Mm-hmm. And it was interesting because during that time I was working for NEHB Research Center, and there was a large research project at that time to see the feasibility of steel framing. Mm-hmm. So I got to travel around to many of the homeowners associations, the BIAs of the country, almost every state in the union, and see what was going on. And back in the early 90s, Hawaii was already at that, during that experimental stage, at 25% market share was going to steel. And nowhere else had that, nowhere else came close. And so from the mid-90s until the turn of the century, Hawaii catapulted into steel framing, where it got up to about 3/4 or more of the homes on Oahu anyway were being framed out of steel, at least the wall framing. So that was very interesting to see that evolution take place in Hawaii. Nowhere else in the world came close to that percentage of homes being framed with that material.
Mm-hmm. Mm-hmm. And I think just besides money, there are a few other advantages to steel framing.
Yeah, there's several, and one of them, well, there's a whole list of them in the slide, but one of the advantages, there's several advantages that come out of steel framing: straighter walls, fewer callbacks. You have
Here's our list.
yeah. This is good. You have the material is made. It's not an organic material, so it doesn't deteriorate the way wood decomposes over time. Steel has other disadvantages to it that you have to control, that we'll talk about later. But you also get LEED ratings, and one of the benefits of steel that gives it the LEED rating is it's the most recycled product in the world. I mean, in other words, the steel studs in a home today are not coming from the mills, so to speak. You're coming from recycled cars, recycled washing machines, recycled steel products that are being melted into new steel products. So it has that recycled factor that gives it a real environmental benefit.
And as I understand it, steel can be theoretically recycled infinite numbers of times, because if you recycle paper, every time you take a sheet of existing paper and put it through the pulping process and make recycled paper, the fibers become shorter and shorter and shorter. Therefore, maximum 6, 7, 8 times can that sheet of paper be recycled before it's pretty gosh darn useless. But I don't think that's the case with steel.
No, steel is a real transition.
Yeah.
When people think steel, they think the old mills, you know, the smoke belching mills around the Rust Belt area, Chicago and Youngstown, Ohio, and all that. But today it's much different. The steel's manufactured through a mini mill, and you have to have you have to have that recycled steel to get it to work. And it uses much less energy to produce. It's much more efficient. It keeps the cost down. So that's, you know, it's not the old dirty steel industry of yesteryear.
Yeah, it's just another environmental benefit. If you're going to manufacture steel from the raw content, you have to go to a mountain or a pit or something and dredge all of these minerals out, and then go through a horrendous process to extract the steel making components from that, then take them to a factory, then melt them down at very high heat and so forth, so forth.
Right. Tremendous energy, and it didn't really have the environmental benefit until you look at steel from the cradle to cradle. Instead of cradle to grave, you have to look at it as coming around 360 degrees and being melted down and manufactured again. And then you see the real environmental benefit of steel and steel framing. It's not just into the framing materials, but in all types of steel.
Yeah, just a little sidebar, no extra charge. Hawaii's leading export. When I was a kid, it used to be sugar, pineapple. Now it is scrap steel.
Yeah.
All of that new construction going on, especially in Asia, some of that comes from Hawaii.
There's very little waste on a steel frame job because the steel members are cut to length. But whatever scrap does result from that job, they can have the recyclers, the scrap metal companies will pay for that scrap. So there's very few waste products, so to speak, that they can get that have value. This is a photograph of a project on one of the military bases here last year, showing all the steel framing and the floor joists and the wall studs and the sheeting that go into that.
And just using this as an example, do the beams and everything get cut on site?
Very few on site. A builder can choose to do that, but a production builder will have these cut to length from the factory. Whether they're shipping them in from the mainland, or we have one plant here in Hawaii that actually rolls the shapes. So they just bring in the coil and then they'll roll the product to length, and it really saves the builder time. A lot of times the floor panels or the floor joists will be assembled on the ground and then lifted into position. They use the benefit of steel. It's lightweight, has a high strength to weight ratio, some of the other benefits that we talked about earlier.
Yeah, I was out on a job site in the Ewa Plains some years ago, and I still remember it vividly because the builder would just construct this kind of open air tent just to keep the sun off. And here would be these great big coils of steel, and it goes through one process and it cuts it to length, and then it goes through another process and it bends it into a rectangle.
It goes right through a series of dies. That's called cold forming. There's no heat involved. It's just a roll forming process, and they can keep rolling, very similar to metal roofing. It's kind of like the sister of steel framing, very similar in rolling the shapes, economizing and using just the material that you need.
Another benefit environmentally is I also deal with recycling of products, and ideally we wouldn't have any waste. And when we started recycling in 1987, we recycled only about 7% of all of our waste. I think those are primarily scrap cars. We are now way above 70%, and we're headed up for 80. But one of the components that we have not been able to recycle is treated lumber. The H-Power, the garbage energy plant, can't accept it because of the toxins that would be emitted. So right now we have a treated lumber problem here.
Yeah, so that's another benefit of using steel. The steel is galvanized, so it has a certain amount of protection. The zinc protects the steel supposedly for the life of the home. Now, there's some exposure issues, just like with the Simpson product, which is made from the same type of material. It depends on what it's exposed to. You wouldn't want to put this outside exposed to the rain every day without protecting it.
Yeah, and finally, let's see, we have one last slide of some, looks like some windows.
Yeah, this particular slide, and this hits right back to the energy code, is showing a project here, a military project on Oahu, where they've decided to, instead of using the trade-offs that we worked on hard in the Energy Code Committee, to use the continuous foam insulation. And this is showing the foam installed on the outside of the steel frame home. They've had to fur out the windows there. They did that with wood. And then they'll put the siding over top of that. But this is the continuous foam insulation, which is one of the ways of satisfying the energy code.
Yeah, let me just back up on this a bit, since we spent many hours on this issue. The National Code says that if you have steel framing, you have to have not just your interior insulation on the wall, but exterior insulation. Why? Because steel transfers heat 36 times as effectively as does wood. So think about it, if you just have a thin cladding, a thin wall material, and you have your hot afternoon sun beating on that wall, the heat's going to go through the wall, into the steel stud, and into the interior. So on the mainland, they said, let's put insulation along the exterior. And we had long debates about this and concluded that that exterior framing would add at least $4,000 to the cost of the home, and the savings would be 385 kilowatt hours. Savings would be about $120 a year in saved energy. $4,000 versus $120 sounds to me like about a 33-year payback.
The continuous foam is better suited for extreme cold or extreme hot climates. A climate like Hawaii, the trade-off is not quite as much. So that's why we worked hard on the local energy code here in Hawaii to lessen that impact with some trade-offs.
So just to promote the Hawaii code for a minute, we did 3 different trade-offs. You could have a light-colored wall surface so that the sun's heat reflected back off rather than penetrating into the wall, or you could have a more efficient air conditioner, or you could have better lighting. And all of those, it's a matter of zero cost to a few $100s rather than these thousands of dollars. And that is one of our great success stories. And on that cheery note, we must bring this program to a close. Thank you, Tim Waite, for getting us anchored down in here and saving our homes from the next hurricane, which is not if, it's when. ThinkTech Hawaii, Code Green. See you soon.
Thank you, Howard.
Hey.